This is a lesson on composite functions. Now that you're able to read function notation, you can start using it to put functions inside other functions. These are the two most common notations for composite functions. This says FOG. I'm not really sure how I would spell that. FOG of x. And on the right-hand side, it says f of g of x. So again, it's hard to say, much easier to write. F of g of x or f o g of x. In reverse order, it's g o f of x or g of f of x. In both of these notations, this right-hand-most function g is considered to be the inside function, and the f is the outside function. That's not a formal name, but it's a good way to think about this. Function g is inside the function of f, and for this one down here, f is inside of g. We can be asked to evaluate composite functions. Instead of asking what is f of 1 or what is g of -7, we can also be asked what is g of f of 3. So before we can move to the outside function, it's going to be a good idea to find out what's going on with this inside function. So the first thing we need to know is what is f of 3. So f of 3 means that we replace the x in the function f with a 3, and we evaluate that. So 3 plus 1 is 4, square root of 4 is 2, 2 minus 7 is -5. So g of f of 3 is g of -5. Now we can move to the outside function, which is g, and we can replace the x here with -5. G of -5 is equal to -5 squared minus 3 times -5. -5 squared is +25. Minus 3 times -5 is +15. 25 plus 15 is equal to 40. G of f of 3 was the same as g of -5, which is equal to 40. We can also be asked to do it in reverse order. So if I wanted to know what is f of g of 3, is it the same thing? So again, we're going to start with the inside function. First of all, what is g of 3? G of 3 is 3 squared minus 3 times 3. Three squared is 9. 3 times 3 is 9. So g of 3 is equal to 0. So now I can replace g of 3 with 0. So I'm looking for f of 0. So now I have to go back to the f function and replace the x this time with 0. F of 0 is equal to the square root of 0 plus 1, all minus 7. 0 plus 1 is 1, square root of 1 is 1, 1 minus 7 is -6. So f of g of 3 is f of 0, which is -6. G of f of 3 was +40, and f of g of 3 is -6. This is typical. It is not usual for the composition being the same in a different direction. We can use these same two functions again to answer two more questions. What is g of f of 0? And what is f of g of 0? We're expecting that they might not be the same answer. Start with the inside. F of 0 means that we replace this x with 0. We've already calculated that. 0 plus 1 minus square root of 0 plus 1 minus 7 was negative 6. So this is g of negative 6. Now we move to this outside function g, and we can replace this x with negative 6. So g of negative 6 is negative 6 squared minus 3 times negative 6. This is positive 36 plus 18, which is equal to 54. G of f of 0 is g of negative 6, which is 54. 2 steps to get the answer because we're dealing with two separate functions. So in the other order, f of g of 0, we're going to start with the inside function g and replace the x with 0. G of 0 is equal to 0 squared minus 3 times 0. That's 0. So we want to find f of 0. G of 0 was 0, so f of g of 0 is f of 0. F of 0 means we replace this x with a 0. We've already done that. It is 0 plus 1, square root of 0 plus 1, all minus 7, which is equal to negative 6. So again, we have two different answers when we reverse the inside and outside functions. It's possible to compose a function with itself. So f of 35 is something that we can calculate. The inside and the outside functions are the same, but it does not mean that f of 35 will be the same as f of 35. I'm going to color this a little bit just so we keep track of what's what. So the inside of this is f of 35. So I'm going to calculate f of 35. F of 35 is the square root of 35 plus 1, all minus 7. 35 plus 1 is 36. The square root of 36 is 6. 6 minus 7 is negative 1. So f of 35 is equal to negative 1. So to compute the composite function value, I now need to find f of negative 1. F of negative 1 is the square root of negative 1 plus 1 minus 7. This is 0. The square root of 0 is 0. 0 minus 7 is negative 7. So f of negative 1 is negative 7, and f of 35 is negative 7. This is another example of composing a function with itself. So g of negative 2. To find this, we're going to start with the inside function, which is g of negative 2. G of negative 2 is equal to negative 2 squared minus 3 times negative 2. This is 4 plus 6, which is equal to 10. Now I can put g of negative 2 and just change that to a 10 because that's what it's equal to. And so to find this answer, I need to compute g of 10, which is 10 squared minus 3 times 10. 10 squared is 100. 100 minus 30 is equal to 70. So g of 10 is 70, and g of negative 2 is equal to 70. Here are a few important and less important properties of composite functions. The first one you've already seen. In general, f of g of x is not going to be the same as g of f of x. So if you think you can avoid a bit of work by computing a composite function one way and assuming that it will be the same using the opposite functions, it will not be the same most likely. It's possible for them to be equal, but composition of functions is one of those math operations that is not commutative. It does matter which one comes first. So for all functions f of x and g of x, their compositions are also functions, and f of x and g of x. That's a pretty theoretical property, but who knows, it might come in handy one day. This is going to be very important for inverse functions. This will help you determine whether two functions are inverse, and later than that, it will tell you how to compute derivatives of inverse functions. So when f and g are inverses of each other, f of g of x will equal g of f of x, and they will both equal x. So that will be more important once you want to know about inverse functions. Functions don't need to be expressed as equations. They can be written as graphs or as tables, and we can still compute or evaluate composite functions. If you are asked to find g of h of 4, the first thing we will do is find out what h of 4 is equal to, and then we can plug that number into the outside function, which is g. So the inside function h of 4 means that we find x equals 4 on the axis, and we follow it up or down until we hit the graph. So h of 4 has a height of 1, so g of h of 4 is the same as g of 1. And now we can move to the g function. G of 1 is 1 squared minus 3 times 1, which is equal to negative 2. G of h of 4 is negative 2. In this example, we have a table of values and an equation, and we can still find a composite value function by using the information that we have. So if I'm asked for g of f of 48, I start with the inside function. What is f of 48? F of 48, I'm going to take x and replace it with a 48, plus 1, minus 7. 48 plus 1 is 49. The square root of 49 is 7. 7 minus 7 is equal to 0, so f of 48 is 0. So I need to compute j of 0. So when x is 0, this is the row that I'm interested in. X is equal to 0. J of x, when x is 0, is equal to 6. So j of 0 is 6, and j of f of 48 is equal to 6. We can compose a function with itself in any form that it's given as long as we have enough information. So I can find j of negative 1 using just the entries on this table. The inside is j of negative 1. J of negative 1 is positive 2. And then I can find j of 2, which is equal to 14. So j of negative 1 is 14. In summary, evaluating composite functions is the same as evaluating any other type of function using function notation, and it's usually easiest to evaluate them by evaluating the inside function first, or the furthest most right function, and then taking that new value and moving it to the outside function. Also, composition of functions is not commutative, so don't expect f of g of x to equal g of f of x. And the most common notations are f o g x and f of g of x, and these both mean the same thing. In each of these, g of x is the so-called inside function, and f is the so-called outside function. In the next part, you'll be learning how to put together general composite functions when you're not given a specific input value.